Today we're doing a deep dive into a piece of hardware that it creates a really fascinating dilemma for anyone managing an industrial facility.
Right. We're looking at the NTI E-H2S-lC.
And like a lot of these industrial names, it doesn't exactly roll off the tongue, does it?
Not at all. But here's the hook, the thing that really grabs you.
It's the price. This thing is listed at $235.
And then right next to it in the catalog, the related standard model
Is $1,210.
Yeah. I mean, that is a massive price gap.
It is. And it forces you to ask a really uncomfortable question.
Is the cheap one dangerous, or is the expensive one just, wildly overpriced?
That's exactly what we need to figure out.
Yeah.
Because we know the stakes with hydrogen sulfide are, well, they're high.
Mm-hmm. It's not just a bad smell. It's corrosive. It's toxic. You really can't get this wrong.
So usually when you see a low-cost label on a safety sensor, you kind of brace yourself. You assume the specs are going to be awful.
Right, but looking at the data sheet for this LC unit, it measures from 0 to 100 parts per million.
Okay, that's a decent range.
Yeah.
But I did look at the accuracy specs. It says plus or minus 10%, or 2 ppm.
Yeah.
In the world of, precision instrumentation, doesn't that feel a little wide?
It does. On paper, maybe. But you have to think about the application here.
Okay.
If you're monitoring, say, a remote pipe chase or a battery room, do you really need to know if the level is exactly 50 ppm versus 55?
No, I suppose at that point you just need the system screen. Get out.
Exactly. It's a threshold device. It's not a laboratory instrument. And honestly, for $235, getting within 2 ppm is surprisingly robust.
And the physical build doesn't seem to cut any corners either. It's IP65 rated.
Which means you've got protection against dust and, low-pressure water jets.
Pretty standard for an industrial environment. You can wash down the walls without frying the sensor.
Mm-hmm. And the temperature range is solid, too. It runs from -4 up to 122 degrees Fahrenheit.
So unless you're putting this thing inside a blast furnace or a cryo chamber, it's going to be fine.
So it's tough, and it's, let's say, accurate enough. But here's where we get to the architecture and where we can explain that low price tag. You cannot just buy this box, stick a 9-volt battery in it, and walk away.
Ah, right.
Yeah.
I did notice that dependency.
Yeah.
It requires the ES5 VDC sensor converter.
That is the key. The LC unit is, well, it's essentially just a sensing head.
I see.
It creates a simple signal, but it offloads all the processing and the power management to that converter.
Which then feeds into the main NTI system, like the E2D or the E16D.
You got it.
So the $1,200 unit probably has all that intelligence built right in, but this one is sort of relying on the ecosystem to do the heavy lifting.
Precisely. It's a distributed architecture. But that dependency, that actually unlocks a huge feature.
Oh.
Because of that converter and the cable, you can mount this sensor up to 1,000 feet away from the controller.
1,000 feet. That's huge.
It is.
So you can have the brains of the operation in a safe, climate-controlled room and run this little $200 nose like 3 football fields away into some nasty basement.
And that creates a very different value proposition. Suddenly, it's not just about one sensor.
Right, because if you have a large facility, the low-cost model lets you deploy, 5 sensors for the price of one of those Perilium standalone units?
Exactly.
That's a really interesting angle on safety. Usually we think, more expensive equals safer.
Right. The gold-plated option is always the best.
But in this case, being able to afford saturation coverage, putting a sensor in every single corner, not just one in the middle of the room, that might actually be the safer option.
I think so. It's like the democratization of safety. You're trading absolute lab-grade precision for much broader situational awareness.
And since it all plugs into the same NTI dashboard, you aren't trying to manage 5 different systems.
You just have to remember to budget for that converter.
Or you're going to be holding a $200 paperweight.
A very rugged, very weatherproof paperweight, but yeah. A paperweight nonetheless.
So to wrap this up, the E-H2S-lC is a budget-friendly, tough little sensor. It handles standard industrial environments, and it slots right into the NTI network.
As long as you have the right converter. And it really challenges that idea that you always need the most expensive tool for every job.
It does. And it leaves you with a final thought to chew on, doesn't it?
Mm-hmm.
We often chase the absolute highest specs on a data sheet because it feels like the responsible thing to do.
Right, you're covering all your bases.
But if a $235 sensor gives you the exact same evacuate now warning as the $1,200 model, are you paying that extra $1,000 for safety?
Or are you just paying for the comfort of over-engineering?
Something to think about. Thanks for tuning in to this deep dive.